t table, if you ever find a value that's on the left side, just put a negative in front of it. And I think that's okay for everyone. I've never had any students have trouble with that, because that would mean we're not going to give you a whole nother sheet for you to copy, right? Yeah, we just need one sheet. We know about symmetry, true? So our critical t value is negative 2.330. Cool? Hey, if anybody's curious and they wanted to get this off their calculator, who does have the nifty new calculators? I will point this out. You would have had to type in inverse t, 0.01, comma, 699 like Gary indicated. And the newer calculators do this, but who's got an 83 like me? Doesn't work on ours, right? Angela, do you have that?
I have it, yeah.
So Ewan, would you hit this? You can tell the class what comes up. She's going to hit this on the calculator. It's going to be, we noticed, just a little off, like the number we saw last class. Let's see what she gets.
Negative 2.331694.
So it had a 1 right there
Yeah.
with the technology. More accurate, but this is good enough, isn't it? Absolutely. We're good to go. So very good, Angela. Feel free to use that negative 2.331. All right, so we found that. That's the inverse t function. I don't have that, so I'll erase that. But that's where you can get it off the new models. There's one other number we got to get to perform this classical approach. It's what we're going to compare to this. It's called the sample test statistic. All right. They label that as T naught, or T sub 0. But I think we should put words next to this so we know what this means. This is called the sample test statistic. All right. Now I want you to notice something. I changed colors of chalk. I think it's good to color code. I only needed this yellow chalk. Look, I'm putting it down. I don't need it anymore. I only needed that yellow chalk from the 0.01 to get my what? My T crit. That's all I needed it for. Does that make sense? See, the rest of the way I'm using this white chalk. Now I'm back to, sample. Now I'm based on my sample results, okay? Just so we're not confused with all these numbers. This critical t value comes from the level significance. And if you're curious, like, what is that level significance? Those three researchers considered anything less than 1% to be rare or unusual. Bless you. So when they began the problem, that's what they were thinking. Anything less than 1%, we're going to consider as unusual. All right? Now, we're going to get this. All right? Now, how do you get this? Well, this is like when we did z-scores. Do you remember the z-score like this? X minus mu. We went like this. Remember this? Mm-hmm. And then if it dealt with sample means, this is what we had to do. We had to do x bar minus mu, and you had to divide the, this is what we did in 8.1. But then we realized something in chapter 9 when we realized, oh, there was some bias involved, and so with the means, when we do inferential stats, we use t rather than z. So it looks like this, but here it is. The formula is x bar minus mu all over the sample standard deviation by divided by the square root of it. And we'll do all these calculations. Hey, just so you're not freaking out, this formula sheet, do you see that on there? Go ahead and look. Look in chapter 10 portion of the formulas, and look where I wrote examples. Does anyone see my examples? Take a second to look at it. So you're just like, man, I don't forget that. The sample test statistic, T naught, it's going to be a number based off our sample. Does anyone see it on there? Yeah? All right, good. So you know it's there, right? In case you forgot that, it's there, true? It's on this one. It's on, do you have that copy of the test? The thing that gets attached to us? You see it right here in section 10 where it says examples. And I got T naught equal to x bar minus the mu. I actually put a mu naught here, but that mu, everyone, is that number right there. That's that status quo. All right, so you and I are going to do all this math. Then we're going to compare this number to this number. Cool? And then we'll have our conclusion. Yeah, we'll almost be done. All right. Let's fill in the blanks. What's x bar?
98.2.
All right, 98.2. Minus, what was the mu for this problem? That's the status quo.
98.6.
Good job. Hey, that's is coming out negative. Yeah, it should be. It's everything's on the left side, right? Okay. What's us? 0.7 and the square root of. All right, Gary. This time I'll use the 700 because it's an n, right? All right. Now be careful typing this in. And you want to do it all at once, you can, but you gotta be careful with the what? The parentheses. So when I'm going to type this all at once on my calculator, but if you like to do it in steps, that's not a bad idea. I'll do it both ways, just so you're fine. It's an important number, so I gotta make sure I don't mess it up, right? So come out here. Let's see what we get here. All right. So parentheses, 98.2 minus 98.6, close parentheses. So when I put parentheses around that, now I hit division, and when I do this division, does everyone see when I wrote this on the board, I put parentheses here? If I try to type this all out at once, I gotta be very careful with these parentheses. Divided by parentheses, 0.7 divided by square root of 700, close that parentheses, and this will be fine. Should be a negative answer, as we know, and that could be the craziest z-score or t-score we've seen in this class yet. But I'm going to write that down, okay? But I did it all at once. If that's too much for you, there's nothing wrong with doing these in 2 steps, okay? And I'm just going to put negative 15.1. Okay? Hey, some students do 2 things at once. They go like this. What's 98.2 minus 98.6? They hit enter. They do the other thing. What's 0.7 divided by the square root of 700? And they hit enter. And then they go, what's negative 0.4 divided by my answer? And when you know where the answer button is, right? Some students prefer to do this because they're worried they're going to mess up all the what? All the parentheses. So it's not a bad idea. And I still get the same number. Cool. Hey, I'm going to hit the lights. Everyone, come on now. Isn't that the most ridiculous or outrageous z-score, t-score we've seen so far? That's way out there. What kind of z-scores do we usually get? 1s and 2s and 3s and negative 1s. Everything in here, right? Where is this thing in this image?
All the way over there.
Oh my gosh. I mean, it's way over here. So this is going to give us an idea of what's going to go on with our conclusion and what we feel about this whole experiment and what we could say about our hypothesis test. But everyone, I think it's important that we all put this in our image. All right? I want us to make a marking. We know where the t crit is, right? Go plot this, like actually in your picture. Well, okay, if I plotted my picture, how far over am I going? Oh my gosh, so I'm like way over here, right? Now this number is way, way over here. I don't even think I exaggerated enough. It's probably even further, right? Mm-hmm. But it's way over here. The key is T naught equal to negative 15.11. And it's called the sample test statistic. That's what it's called. Evan, can you make this observation for me? Is it in the yellow region? That yellow region that dealt with this level significance. Mm-hmm. So what I'm doing now is, remember how we said this bell curve continues forever? Well, doesn't this yellow shaded region go on forever? Mm-hmm. This is called the critical region. If you're wondering, this yellow region, it's called the critical region. That's the T crit value. But what's so important that we have to do at the very, very end of performing the classical approach is to determine whether or not our sample test statistic fell in the critical region. Does it? That's what we got to look at. We got to make that observation. So the picture is actually important. It's important to make this picture. Everyone, is our sample test statistic falling inside some portion of the critical region?
Yes, it does.
All right, so bless you. Put this in your notes. This is what we do with hypothesis tests. So I'll start with it. If your sample test statistic falls inside the critical region, we are going to reject the null. I'll say that a couple times. That's what we're going to do for every hypothesis test. Every hypothesis test Once we're going to compare two numbers, right? There's going to be a t-crit and a sample test statistic. If our sample test statistic falls inside the critical region, you go, what are we going to do? We are going to reject that null hypothesis. Now, I'm sure you're wondering why. Don't worry, I'll explain why before you leave today. Because you might be going, okay, but why? I get it. I get it, Professor, but why? And we'll get to that. I want to explain why. It's all based on probability. This whole thing was based on actual probability. Right? What's the probability it's going to, like, rain today? Or what's the probability somebody dies next year? And all that stuff we talked about in this course. But I'm going to say one more time, oh, you bet. If your sample test statistic, it's that T naught thing, if it falls inside the critical region, which you already have drawn, we reject the hoe. You know what I mean by the hoe, right? Yeah, you should get it. The null hypothesis. You can write that. The H naught, we reject it. So guess what, everyone? What if it doesn't fall inside the critical region? What if it falls like here?
We accept it.
Then we do, yeah. And we can't say accept because it's like the courtroom, you're saying someone's innocent, right? So we'll say we do not reject it. Right? Just like in law, we never go, we find him innocent, Your Honor. We just go, we find him not guilty. We just say we do not reject. Not guilty, we do not reject. We would say that if it fell somewhere over here. No, we're going to be rejecting the null in this thing. Do you agree?
Mm-hmm.
I mean, if you want to go up to the side, we already know with this problem, what are we doing? Reject what?
Null hypothesis.
Reject the hoe. That's what we're doing with this problem, aren't we? Reject it. Reject the H naught. All right, we're rejecting it. Now, when we're ready to write the conclusion, we can make a concluding statement right now. All right, so we're rejecting the hoe, right? I will write that again, so I'll erase it. I sure I like that. But we all know we're rejecting this thing. We're basically saying what? Reject you, go with this, right? We're like, check mark, you're out. This is what's going on here. Do you follow me? And someone spent a lot of time and money on this, but it looks like their educated guess was pretty much going with what they thought. All right? Cool. Here's our conclusion. So you and I are going to state the conclusion. State the conclusion. State the conclusion to your hypothesis. And when we say the same thing every time, it's kind of cool. We either say there is evidence, or we say there is not evidence. All right? And when in this case, there is evidence. You might say there is strong evidence. There is evidence suggesting that, I'll wait till I write that. There is evidence suggesting that, we use words like suggesting in stats. We're never 100% accurate, right? We estimate. There is evidence suggesting that, and I'm just going to write this. I'm just going to write this right here. You always state the alternative hypothesis. That mu is less than 98.6. You don't write the 98.2. You don't write the 98.2. If you want to use words, you could say the population mean is less than, if you want to put words in there, but it's okay to write it like that. So let me emphasize this. When you state your conclusion, you always refer to this. Somehow in your conclusion. You will always say this somewhere. Why? Because that's what you were putting all the time into. That's what these researchers were trying to look at. They were trying to look at this. So you got to state it in your conclusion, right? Well, there either is evidence or there is not evidence. When this falls into critical region, there is evidence. Okay? Hey, just so everyone has this. What if the sample test statistic came out over here? Then we would have said the same statement, exactly word for word, but right here I would have put the word not. And I would have said, there is not evidence. Right?
Not or no evidence.
Yep. You can say that. That's good. Because there's no evidence. You can say there's not evidence, but even better, I like the there is no evidence, suggesting that. What's most important, or what we can't say is, we're keeping the null. We can't say that, because that's just like in law saying, oh, we find him innocent, Your Honor. we just say there's no evidence.
But
Right?
who came up with this nomenclature? Like, is there a, like,
Oh yeah, it's this stuff based off just like with you see in terms of law and how people are arguing versus we find them guilty or not guilty. It's the same thing. We're saying either we're gonna what reject or not reject.
no,
I know. Because we gotta assume like if we said keep that, there might if we didn't have the evidence, maybe we screwed up something, right?
Huh.
Maybe we messed something up in our studies. Not a numerical error, but maybe there was what some kind of bias involved. Or some kind of lurking variable, or some kind of confounding factor.
Yeah.
So because of all these other factors that we're not aware of, we just say, all right, there is evidence or there's not evidence.
No.
We reject this or we do not reject it. Hey, everyone good with this? Awesome, Sierra.
So if, so like you were saying about if the sample test statistics falls outside of the critical region, then we fail to reject the null hypothesis.
That's true.
And then in the conclusion, it would be, there's no evidence suggesting that mu is less than 98.6. Okay.
You nailed it. And when Sierra was perfect. She was saying if that sample test statistic, which was negative 15, came out over here like negative 1.3. She started out saying there is no evidence suggesting that mu is less than that. That's what she's saying. She also mentioned that you would fail to reject this. That's what she said. She goes, you would fail to reject this. We just can't say you would keep it. You can whisper it to yourself though, right? I think the best word art you can say is retain. You can be like, oh, we're retaining it. We'll retain it. It keeps such a strong word, it sounds like, oh, it's right. We're like, well, we just didn't have evidence to go against it. That's all.
Are you going to ask us to state both in the test, like what Sarah just said?
Oh, no, this is fine. This is, when it comes to conclusion, you can just every time go, there is evidence or there is no evidence suggesting, and you always report what? The alternative hypothesis in your conclusion statement. Now we're going to do, Holland, we're going to do another test. I left some room over here, everyone. There's another test we're going to do. It complements this.